Now we want to more or less repeat example 5, but this time we have a quadratic function instead of a linear function. So as our function becomes more complicated, we're going to have more work ahead of us to arrive at this final answer. But our steps, our general steps along the way are the same. We'll first find f of x plus h, which means we'll find negative 5, and then in place of x, we'll plug in x plus h. That quantity squared plus 4. Now what we need to do is expand out and simplify. Expanding out x plus h is the same thing as taking x plus h times x plus h. So foiling that out will give us x squared plus 2xh plus h squared plus 4. Now distributing through the negative 5, this will leave us with negative 5x squared minus 10xh minus 5h squared plus 4. Our next step will be to find f of x plus h minus f of x. F of x plus h is again the expression we just found above, minus 5x squared minus 10xh minus 5h squared plus 4. And then we'll subtract in a set of parentheses f of x, which is the original function. Substituting in with those parentheses should again help us catch that this negative is going to distribute to both of those terms, which will leave us with negative 5x squared minus 10xh minus 5h squared plus 4. And then once we distribute the negative through, we'll get plus 5x squared minus 4 all over h. Then we'll see that minus 5x squared and 5x squared cancel. So do 4 and negative 4, which will leave us with negative 10xh minus 5h squared all over h. In the numerator, we have a common factor, which is h. Actually, in this case, 2h, but really we just need to worry about the h. We're going to factor out that h in the numerator. Which will leave us with negative 10x minus 5h all over h. H over h will cancel, leaving us with just negative 10x minus 5h. Here we had h over h cancel. We had that in example 5 as well, and that's going to be a key step in evaluating these problems. Because as you can see in part C, we need to take the limit as h approaches 0. That means we can't have h in the denominator, otherwise direct substitution would fail. We wouldn't be able to evaluate the limit that way. So the goal is always going to be to get that h in the denominator to cancel, and then we should have a relatively simple limit problem to evaluate. So that means f prime of x, our derivative function, is equal to the limit as h approaches 0 of negative 10x minus 5h. Again, since we eliminated that h in the denominator, we can evaluate this using direct substitution, and we'll just be left with negative 10x minus 0 or negative 10x. Now we have two new pieces for our problem. In part D, we want to find the value of the derivative function at x equals 3. That means we want to find f prime of 3, where f prime is that notation for the derivative, and we found that derivative function in part E. So to evaluate this, we'll take x equals 3 and plug it into that derivative function to get negative 30, where negative 30 is the instantaneous rate of change of our function at the point x equals 3. And we could continue to find the instantaneous rate of change for other points by plugging in other values. But here the last thing that we want to do is find the equation for the tangent line to the curve at x equals 3. Meaning we want to find an equation of the form y equals mx plus b, where we just found the slope of that line, the slope of our tangent line, should be negative 30, since that's the instantaneous rate of change of our function. And then we need to plug in values for x and y to solve for b. One trick here is to keep in mind that when we are looking for our values for x and y to substitute, we need to go back to the original function. We need to know what that passes through. So we need to go back to the original f of x function, not f prime of x, and evaluate that at x equals 3, which would end up giving us a value of negative 41, meaning for the original function, it passes through the point 3, negative 41. So notice that we didn't use the derivative function here, we went back to the original function. Once we have that xy pair, we can substitute that into our equation. To get negative 41 is equal to negative 90 plus b, and then we'll add 90 to both sides. To get 49 is equal to b, meaning the equation for our tangent line at this point is y equals negative 30x plus 49.